अस्सलाम वालेकुम स्टूडेंट्स, कैसे हैं? ठीक ठाक, खैरियत? अच्छा, I forgot that today's class at 3:10, but now I'm on the way to Peshawar, so I remembered right now. So we will not take class on team today. I'm just recording a few things and I will share that on WhatsApp. And please, at the time of your class, you will send me your registration number for the sake of attendance. And if you have any question, you can ask me, okay? So I'm just recording that for you. So in the last lecture, I think we had discussed about diffusion and adhesion. So these two are the topics which we will discuss today. As I had told you that there are several parameters which affect diffusion. This is not only concentration gradient which affect the diffusion. There are several other parameters, like for example, what's the size of the atoms, and what are the easy paths. I had discussed with you what are the easy paths. The easy paths are, like for example, grand boundaries and the cracks and any kind of dislocations. So these are the voids and vacancies. If there are present vacancies, if there are present porosity, if there are present dislocations, if there are present grand boundaries, then these grand boundaries, these dislocations, these defects will provide easy paths for the diffusion of atoms. And similarly, if you read the Evener book, in that case, and that you will see that diffusion also depends upon the chemical activity of the metals. If there is of the atoms, if there is a chemical reaction, then obviously that will affect the diffusion. If a chemical compound is formed, then there will be a difficulty in diffusion of atoms. But if there is no such kind of formation of chemical compounds, then obviously the diffusion will be easier. And also, as I had told you that through grand boundaries diffusion is easier, but through the grains the diffusion is a little bit difficult. So easy paths are these defects, which are line defects, vacancies, porosity, and grand boundaries, etc. Similarly, as I had told you that diffusion also depends upon concentration. You know about that. If there is more concentration on one side of atoms A and there is less concentration of those atoms on the other side, then atoms will diffuse from higher concentration to lower concentration. But there is another very important parameter, and that is temperature. So if temperature of one side is more than the temperature of the other side, then obviously solubility of atoms will be more at that point where temperature is higher. Okay, so at higher temperature the solubility will be more, and therefore there will be diffusion of atoms towards that region where solubility is more. Okay, but solubility of atom in the solid state is more at higher temperature, but in some cases, like for example solubility of gases in liquid, that decreases with increase in temperature. To say in general, the solubility where solubility is more, then direction of concentration will be that region. Direction of diffusion will be that region where solubility is more. So if solubility is more because of high temperature or because of low temperature, then diffusion direction will be that one. Okay. Another thing which is very important in all kinds of coatings, the most important parameter is the adhesion. If you have a very good coating and that match all the properties, and that exhibit all the properties, and that can have a resistance to corrosion, that have a resistance to erosion, that have a resistance to hardness, whatever that application might be, and that match that application. But if there is low adhesion, then that type of coating will be of no use. So it's important that all kinds of coatings must exhibit good adhesion strength. So If you are considering thermospray coatings, then the adhesion mechanism is mechanical interlocking. If you are considering electrodeposition or some kind of metallurgical interaction, is very important. So you need to make a coating with reasonably good adhesion strength. So let's say, for example, if I'm interested in thermospray coatings and I want to improve the adhesion strength, then in that case, mechanical interlocking is the dominant adhesion mechanism, and therefore I will try my best to improve the adhesion strength. So how I can do it? It can be done like, for example, by roughening the surface. If you increase the average roughness value by sandblasting or grit blasting, then the RA value, average roughness value, is increased, then adhesion strength will be much better. Similarly, as I don't know if I have discussed with you, if the surface is clean, then there will be a very good adhesion strength. But if there is some kind of impurities, some kind of oxides, some kind of the previous coatings, then as any kind of grease or some kind of organic and inorganic materials upon the surface of a substrate, then these impurities, these defects will create the crack initiating regions, and that will decrease the adhesion strength, that will reduce the adhesion strength very much. So before thermospray coatings, you need to improve its surface roughness value by sandblasting, and similarly in some cases heating of substrate is very important, because if you are heating it, then that will result in better adhesion, better wettability of the substrate material with the coating materials, and therefore that will also improve the adhesion strength. So adhesion strength can be improved by increasing the surface roughness value, by increasing the cleanliness, by sometimes its temperature is increased, and there is a temperature which is called the critical temperature. So above the critical temperature, what will happen that the coating which is made, or the substrate, which is the building block of thermospray coatings, that will be a disc-like, and therefore that disc-like structure will result in better adhesion and better cohesion and better wettability of the substrate material. So better wettability of the substrate materials, which means that adhesion strength will be high. So you need to heat the substrate materials in order to make the disc-like structure, in order to achieve the disc-like structure, in order to achieve the better adhesion and cohesion of the coatings. And similarly, you need to clean it because any kind of impurities upon substrate will result in the crack initiating regions, which will decrease the adhesion strength very much. So you need to clean it, you need to roughen it, and obviously another important thing, you need to know what kind of substrate material you are using. Like, for example, if you are using titanium materials, so which get oxidized very quickly when it is heated. So in that case, heating may not results in better adhesion strength, rather that will result in lower adhesion strength. So you need to know about that thing as well. So what are the substrate materials, what is the hardness? If hardness is more, then obviously then will be the materials which you are spraying will bounce back, and that bouncing back will result in lower coating efficiency. So you need to understand everything, and then once you make a coating. Similarly, if you are using electrodeposition, so you need to clean it, you need to have the materials, the substrate materials and the coating materials mutually compatible, and there must be some kind of metallurgical interaction, because in that case metallurgical interaction is the dominant adhesion mechanism. In that case, roughness is not the dominant mechanism, rather metallurgical interaction is the dominant adhesion mechanism. So you need to know what method you are using, what material you are using, what substrate material you are using, what coating material you are using. So you will decide upon all these parameters. So this is not so simple. You need to know about everything, and then once you make a coating, and then there are some methods for its qualification, for its testing. most important method is the tensile adhesion test, which we are using for thermospray coatings, and according to STM standard. I don't remember the designation, but if you are interested, I will share with you the designation and the STM standard for that. But there is a tensile adhesion test which is used for coating adhesion of the for the adhesion strength of the coating which are made through thermospray coatings. And that case, you take a substrate material, you take a coating materials, and then what will happen that you will join this by means of an epoxy. Standard epoxies are available, and then these just like tensile test you are conducting in your lab, this is similar to that. You are just pulling the two parts, and the strength where the epoxy breaks, that is the strength of the coating. Sometimes not the epoxy, rather the coating break, that is the strength of the, and that is the strength of the coating, that is the adhesion strength of the coating. So please, I want to correct this. I said where epoxy breaks, where epoxy fails, that is not correct. So I want to correct it. Where the coating breaks and the epoxy does not break, that is the strength of the, that is the adhesion strength of the coating. Okay, so that is the adhesion strength of the coatings. So in case if epoxy breaks, then the strength of the coating, the adhesion strength of the coating will be more than that of the epoxy. Okay, so these are the things. And if you have any question, you can call me through WhatsApp. Okay, if you have any question, so you can ask me through WhatsApp, and I'm here. I will share with you this recording, and if you have any question, you can ask me. Please share with me your registration numbers for the sake of attendance, and today we will not use team. Okay, thank you. Allah Hafiz.